Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at an aspect of geometry, and this basically is going to be dealing with the concept of triangles. Now we have already looked at various aspects of what we refer to as triangles, and a number of ways that we have come across in some of our videos in trying to describe the concept of triangles. Now I'm going to put a link of those specific videos in the description box in form of a playlist. Kindly go and check, and of course that is going to assist us in trying to understand the subsequent videos that we're going to do on the same topic. So in this particular case, I'm going to go or have an overview of our 180 degrees theorem. And of course, in our study, various study of topics in sciences and mathematics, we have come across rules, laws, and of course we have come across like the Newton's laws of motion, some specific like the Hund's rule in chemistry and other areas. So we are going also to come across what we refer to as postulates, and of course what we refer to as a theorem, etc. In our study of scientific methods, I mentioned to this specific, I'm going to put a link of that specific video. So I've described in details of these various aspects of course, scientific methods and some of the ways in which you can be able to characterize them. And this is going to dictate on how we can be able to view or perceive some natural phenomena, and how we can be able to, of course, relate them in our day-to-day application. So in this specific case, we're going to deal with the concept of a theorem. Now, in contrast with the laws normally constitute of statements which have been considered from all aspects and have been concluded to be true. Now, for the theorem, we are going to consider some cases whereby this is going to have conditions whereby in some cases it's going to be true, or in some cases whereby those conditions do not exist, and therefore that specific aspect is not going to apply. Now, in this case, we are going to look at the concept of a 180 degrees theorem. So therefore, we are going to consider this specific theorem in some aspects or particular conditions, which of course are going to be assisting us make a conclusion on the same. So we had mentioned about parallel lines, and we said that if we have two parallel lines for M and I, we can be able to give these ones as I is parallel to M given as such, and therefore if you have a transversal that is running across that one, let's give this one as T naught, and therefore that is going to constitute a transversal. And we have said about this aspect of a transversal and various degrees which are going to be achieved from this specific intersection of a transversal and those two specific lines for corresponding and alternating angles respectively. Now if I introduce a second transversal, which is a T1, we're going to see that the intersection between those two parallel lines and the two transversals are going to form what we refer to as a three-sided figure, and this is going to be a triangle. So therefore we can be able to allocate these different angles for W, where perhaps I've already used a T in the odd. So this one has a naught and 1, so this is different from that. And as well, we can be able to describe these specific angles of a triangle. So these are going to be interior angles of a triangle given as X, Y, and Z are given as such. So from so this theorem is going to have a statement that is going to be a summation of these angles X, Y, and Z is equivalent to 180 degrees. Now it's upon us to, from the various aspects of alternating angles, corresponding angles, and of course angles of a line, and try to see whether the statement basically is going to make some sense for us. So in this case, if we try to look at this, then therefore we can be able to conclude from algebra that the sum of x plus y is going to be described as 180 minus z, or the x degrees is going to be described as 180 minus y plus z given as such. So you can be able to do different maybe evaluations for that specific formula and try to come up with various angles. So we said that if line I and M are going to be parallel, then therefore from the from the addition of angle postulate, which we said that x plus y plus z is going to be 180 degrees, then therefore we can be able to conclude that these interior angles are going to make a sum of 180 degrees. Now, we said that from the alternating angles for these specific parallel lines, these angles are going to be the same. So if we look at the alternate angles for W, the alternate angle for W corresponding alternate angles for W is going to be X. So we can be able to conclude that W, so let's start from this. So if the line I and M are parallel, we have said that X plus Y plus Z is going to form 180 degrees. And this is going to be from the angular addition postulate that we had mentioned earlier in one of our videos. So we can be able to also have another observation whereby we're going to have W equivalent to X. And this is going to be from a conclusion from the alternate interior angles that we had mentioned before this specific discussion. And therefore, we can also be able to describe Z in terms of this specific argument, whereby Z is equivalent to T from the alternate angles postulate that we had, of course, or angular addition postulate that we had mentioned. So this case for alternate angles, for interior angles, we can be able to have a relationship for X and Z by equating them to W and T respectively. So therefore, we can be able to conclude that from substitution, we can be able to conclude that basically X, Y, and Z are equivalent to 180 degrees. And this is going to give us a general conclusion, whereby we are going to see that the sum of measures of three angles in a triangle will always add up to 180 degrees due to this. So if you can be able to look at it in a summary form, we have said that the angles range of a line, which is going to constitute W plus Y plus T, which is going, of course, to be different from this one, is going to make a total of 180 degrees, whereby angle W plus Y plus T is going to be a stretch of an angle. From the lower side is going to be a stretch of an angle of a line MI, which is going to be 180 degrees. So if we try to consider this, then therefore we're going to see that Y is going to constitute an interior angle of this specific triangle. And for T, since T is equivalent to Z, then therefore we can be able to substitute this one for Z. And W, due to the alternating properties, we have said that that one is going to be forming also an equivalent angle to X. So therefore, this equation can be written in terms of X, Y, Z is equals 180 degrees. And that is going to form our 180 degrees theorem for this specific aspect of a triangle that I've given on the board. So this one, in addition to others, as we are going to do an evaluation, we're going to see that they are going to assist us in trying to, of course, do an evaluation of various angular extensions in space and other geometrical figures that we are going to come across in sciences and mathematics. So that is it for now, guys. Bye. Catch us in our next video, and kindly subscribe to our channel for more videos on the same. God bless you. Bye.